everyone, welcome back to the channel. Today, in the Windows System Monitoring Practical series, we will be performing detailed CPU monitoring using Task Manager. We will analyze processor utilization, workload behavior, threats, handles, virtualization support, and real time CPU activity. So, let's start right now. Now, we are inside the CPU performance section of Task Manager. This area provides real-time visibility into process utilization and overall system workload. CPU monitoring is extremely important because the processor is responsible for executing instructions for application services and operating system operations. The utilization percentage represent how much processing power is currently being consumed by the system. In this case, the CPU is operating at approximately 10% utilization. A low percentage usually indicates the system is under light workload, while consistently high utilization may indicate heavy processing activity or performance bottlenecks. For example, during antivirus scans, gaming, virtualization, or data processing tasks, CPU utilization may increase significantly. The CPU graph displays CPU activity over the last 60 seconds. This helps administrators visualize workload fluctuations and identify success spikes in processor usage. Here we can observe moderate variations in utilization, indicating active system operating occurring occur. Here we can observe moderate variation in utilization, indicating active system operations occurring in real time. Performance graphs are useful for identifying recurring spikes, unstable workloads, or resource intensive application. The current speed value represents the processor's active operating frequency at this moment. In this case, the CPU is currently operating at approximately 2.16 gigahertz. Moderate processors dynamically adjust clock speeds depending on workload requirement, thermal condition, and power management. When workload increases, the processor may automatically increase frequency to deliver higher performance. The base speed represents the processor's standard designing operating frequency under normal condition. This serves as a reference point of expected processor performance. Depending on workload and power optimization, the actual speed may operate below or above base frequency temporarily. Modern CPUs use technologies such as boost clocks and dynamic frequency scaling to optimize performance and efficiency. The processes count represent the total number of active application, services, and background tasks currently running on the system. Each process operates independently and consumes system resources such as CPU time and memory. For example, browser, antivirus software, system services, and monitoring tools all run as separate processes. Threads are smaller execution units running inside processes. A single process may continue multiple threads performing different tasks simultaneously. This enables multitasking and parallel execution within applications. For example, a browser may use separate threads for rendering web pages, handling audios, running scripts, and managing network activity. Handles represent references that processes use to interact with system resources such as files, registry keys, windows, network connections, or devices. In simple terms, handles helps Windows manage access to operating system resources. A very high or continuously increasing handle count may sometimes indicate software instability or resource leaks. The uptime value represents how long the operating system has been running since the last restart. This matrix is useful during troubleshooting because prolonged time may sometimes contribute to memory accumulation or resource degradation. In enterprise environments, administrators often monitor uptime when diagnosing stability or performance related issue. Stockade core logical processors. Here we can observe processor architecture details. The system currently contains only one CPU socket with 8 physical cores and 16 logical processors. Logical processors are created through technologies such as simultaneous multi-threading, allowing the CPU to process multiple execution threads efficiently. Virtualization support is currently enabled on this system. This feature allows the system to efficiently run virtual machines and hypervisor based workloads. This is especially important in a cybersecurity lab, SOC environments, and malware analysis setups where virtualization is commonly used. Cache. CPU cache is highly speed memory located inside the processor used to store frequently accessed instructions and data. Cache memory improves processing efficiency by reducing the need to repeatedly access slow system RAM. Overall, the CPU performance section provides administrators with a real-time operational overview of process workloads, system activity, and performance behavior. These metrics are extremely important for troubleshooting, performance optimization, and infrastructure monitoring. Now, I am going to intentionally generate CPU loads to observe real-time utilization changes. As you can see, CPU usage increases dynamically when additional workloads are introduced. This is exactly how administrators identify resource intensive activities. In this part, we analyzed CPU utilization and processor behavior using Task Manager. We also generated real CPU load to observe workloads fluctuation in real time. In the next part, we will monitor system memory and understand how Windows manages RAM resources. Thank you for watching. See you in the next video.